Okay, so good evening everyone. As you know, my name is Rahul Kumar. So this week I will discuss about the matrix properties and inverse. So let's go to the one note. Okay, so let's talk about first operation on matrices. Okay, so first two matrices. Two matrices are said to be equal if they have the same size and their corresponding entries. Okay, so let's talk about let's a matrix A of dimension m by n. Okay, so it can be represented as in the form of ij, which means that when you vary I from 1 to m and j 1 to n, so it can be represented as the matrix form of aij. And suppose there is another matrix that is also of dimension, or you can say size, as m by n and ij. So this thing is saying like, if a equal to b, then it implies that a ij equal to b ij, which means that dimensions should also be same, and also each corresponding entries from matrix A and matrix B must be same. Okay, so second property, if A of dimension m by n and B of dimension m by n are of same size, then A plus B can be written as A ij plus B ij. I know that there will not be problem for you guys, but still for the sake of completion I am doing that. And A minus B can be written as Aij minus Bij. Okay, similarly, suppose if we have a scalar C and you are multiplying with matrix A, then it can be written as C times Aij. Okay, so this is the second property. Now let's talk about the matrix multiplication. Okay, so if matrix A of size m by x and matrix B of size x by n, okay, then C equal to, it can be written as A times B, and also if you want to represent the matrix C like this, then it can be written as A im and B mj, which means that if you want to know each corresponding element of matrix C, then you have to sum by index m. Okay, so if you sum by index m, then it can be written as A I1 B1j plus A I2 B2j plus A I3 B3j and plus plus plus. Okay, So this is the matrix multiplication operation. Suppose if you have a matrix like A equal to A11, A12, B21, oh sorry, A21, A22, okay. So the size of the matrix is 2 by 2, and another matrix, suppose matrix B of size 2 by 3. So it will have 2 rows and 3 columns, which means that B11, B13, sorry, B12, B13, B21, B22 and B23. Okay, so if you want to multiply matrix A and B, then C equal to, it can be written as A 2 by 2 and B 2 by 3. So you can see that this size is matching. So what we can write? It is saying like, if you want to write Cij index, okay, which means that if you want to write Cij, means I equal to, if you want to write the first entry, this entry, so this entry means what? I equal to 1 and j equal to 1. So which means that it can be written like, if you want to write C11, then what does it mean? Which means that A11, B11, okay, plus A12, B21 plus A13, B31, which means that this multiplied by this, okay. So the multiplication of this row and this column will be written in this index, and this index is what? I equal to 1 and j equal to 1. Similarly, if you want to write this index, which means that I equal to 1 and j equal to 2, that means that this row will be multiplied by this column. So every entries can be filled. So this is the matrix multiplication. Okay, so now let's move to transpose of the matrix. Transpose of matrix. If a matrix A of dimension m by n and its elements are like Aij, then A transpose will be of size n by m. Okay, so you can see that whatever the order of A is, it is just transposed by n by m, which means that if you want to write A transpose Ij element, then it will be transformed by Aj I. Okay, so this is the transpose. Now let's move to the trace of matrix. I'm going a little bit faster because I know that you guys already know all these things. So okay, so if A is m by m, which means that it is square matrix, which means that trace is only defined for square matrix, then trace of A equal to what? A11 plus A22 plus A33 plus dot 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 AMM. Okay, so this is the trace. Is there any problem up to here?
No, sir.
No, sir.
Okay. I hope you already know all these things, okay? Is it right or not?
Yes, sir.
Yes, sir.
Yeah, okay. So that's why I'm going faster, okay? So now, properties of matrix operation. Properties of matrix operations. First, AB and BA need not to be equal. Is it correct or not? Tell me.
Yes, sir.
Do not follow. What kind of properties we say? If AB is not equal to BA, suppose if AB is equal to BA, then what kind of property is that? Commutative property, okay? It is called as commutative property. Here AB is not equal to BA, which means that they do not follow, it doesn't follow the commutative law of multiplication. Matrix doesn't follow the commutative law of multiplication. If, next property, if A and B are of same size, then property number 1, A plus B equal to what? B plus A. What kind of property we say is?
Associate.
Commutative law of addition. Okay, and property number B, if A B plus C equal to A plus B plus C. What kind of property is this? Tell me. And third property, A times B.
Associative, sir.
Yeah, associative property. Associative law of addition. And A times bracket BC can be written as A times B out of the bracket C. What kind of property is this? Same property but of multiplication. Multiplication. Okay. And if you can write A times B plus C equal to AB plus AC, then what kind of property is this?
Distributive.
Distributive.
Yeah. Okay. And also B plus C times A, it can also be written as BA plus CA. This is called distributive law of addition. Okay. And last property, if AB equal to AC, okay, then it doesn't mean that B equal to C in general. Is it correct or not? It is called cancellation. Cancellation law doesn't hold. Doesn't hold. Is it correct or not? In matrix.
B is not equal to C, no?
Oh yeah.
B is not equal
yeah.
to.
B not equal to C. In general, sometimes it happens. Sometimes, many times it happens. But there is a catch. There is a condition. What is that condition? Tell me.
A is identity matrix.
Yeah, that is also correct. What if A is not identity matrix? The main condition is A should be non-singular. Okay. For example, if you take A equal to 0, 1, 0, 2 and B equal to 1, 1, 3, 4, C equal to 2, 5, 3, 4, then you can see that AB equal to AC, and that is nothing but 3, 4 and 6, 8. Okay, then you can see that AB exactly equal to AC, but B and C are not same. Why? Because A is singular. Okay, I will talk about it later, but in general it is not equal to B, not equal to C. Okay, is there any problem here? Tell me.
No, sir.
Yeah, okay. Okay, let's move to the inverse of the matrix. Properties of inverse. I already talked about the row reduced echelon form, right? So the first property is if R is RREF of an n by n matrix, then either R has a row of zeros or R is the identity matrix. Is it correct or not? I already talked about it, right? But I didn't talk about the zero matrix. If suppose if you convert some matrix and you are doing the some elementary row operation and you are achieving, you are going towards the row reduced form. So maybe you will go to the zeros matrix. I mean all entries are zero. Then that is the exception case. But in general R is a identity matrix. Okay. Is it fine or not? Tell me.
Yes, sir.
Yeah,
Sir,
because
all the RREF are not square matrices indeed.
yeah, but here I am talking about if RREF is a n by n square matrix, then either R will be all zero entries or it is identity matrix. I'm talking
Okay,
about
sir.
that matrix. Okay, okay. Yeah. Okay, next. If A and B are square matrix such that AB equal to BA equal to I, that is identity matrix, then A is said to be what? Said to be, first it is called invertible and B is called what?
Inverse of A.
Yeah, inverse of A. Okay, or you can write B equal to A inverse. Okay, and there is a condition here. If no such matrix B can be found, then A is said to be what? Said to be, if you are not getting such B, then A is said to be what?
Singular.
Yeah, singular. Okay. Now you guys are using your brain. Okay, so let's take an example. Suppose I already talked about it, by the way. For example, A equal to 140250360. Okay, it is clear that it is what? What kind of matrix is this? What kind of matrix is this? Suppose if its inverse is B. Okay, suppose its inverse is B such that its elements are like this. You're not saying what kind of matrix is this?
Singular.
Yeah. So you can see that if you multiply B by A, then you can see that all elements are maybe non-zero, but columns are zeros, which means that it is nothing, I mean it is not equal to identity matrix. Why? Because A is singular matrix. Okay, now let's move to the property number 3. If B and C are both inverse of A, then B equal to C. Is it correct or not?
Yes, sir, correct.
Can you prove this? Yeah, it's correct. Do you have proof of this? Or just tell me how we can prove this. Okay, let's prove this. If B is the inverse of A, what does it mean? I can write BA equal to I, right? Now, post multiply this matrix by C. Okay. Now, what kind of property I can use this? What kind of property is this?
Associated.
Associative. At the place of AC, what I can write?
C.
Huh? What?
B into C.
No. B times
B
AC.
into A into C.
It is saying like B and C are both of inverse of A, which means that A inverse is also equal to B and A inverse is also equal to C. So what does it mean? It means that AB equal to also I and AC equal to also I. So at the place of AC, what I can write? BI equal to C, which means that B equal to C. This is the proof. Is it fine?
Yes, sir.
Yeah. Now let's move to the next property. If A and B are of same size and inverse of AB exists, then AB inverse equal to what? AB inverse
BA inverse.
B inverse A inverse. Do we have proof of this? I know that the gate will not ask the proof of all this, but still, you know, you must have the ideas. Can you prove this?
Hello, sir.
Yeah.
Can question will come na? In that question we have to use this property in
Yeah.
GATE exam.
You know, if GATE exam wants to ask some, you know, logic things, then they can ask anything. They have to just move around the sentences. They can ask anything if they want to ask. Tell me, Can you prove this? It's a very easy proof. I just want to multiply two matrices. I'm just taking two matrices, B inverse A inverse and AB inverse. No, not AB, just AB. What is the result? B inverse and A inverse A B, right? This is what? Identity matrix and B. This is what? Identity. Then you can see that there is some kind of matrix which are multiplying by AB and it results identity matrix, which means that what? This is the inverse of AB, which means that it implies that AB inverse equal to what? B inverse. You might be smiling. What kind of rubbish of this proof is? But this is the proof. I'm just considering any arbitrary, I mean you can consider anything. I'm just multiplying this by AB. Then you can result its identity matrix, which means that what? The inverse of this is what? This. Because I know that if AB equal to I, then A is inverse of B, or you can say that B is inverse of A. So that kind of property I used. Fine? Is it fine or not?
Yes, sir.
Yes, sir.
Yeah. Now let's move to the next property. Power of matrix. First, a raised to the power 0 equal to what? Now you guys are getting afraid of giving the answer, because in matrix it can be anything. It is not just a multiplication of two scalars. What is a raised to the power 0? Don't afraid, it is just identity matrix. Okay, and a raised to the power n equal to what? If n is greater than 0. Tell me.
0.
Okay, n factors. Okay, a raised to the power minus n. What is this? 1 divided by a raised to the power n. Is it correct or not?
No, sir.
Yeah, then
Yes,
what is
sir.
this? What could be the answer? Simply a raised to the power a inverse into a inverse into a inverse n times n factor. But there is a catch here. If a is what? Invertible. Okay. Now tell me, a raised to the power r, a raised to the power s. What is this? And a raised to the power r raised to the power s. What is this? A inverse and what is this? What is this? What is this?
So third one is A.
Okay, first one.
A to the power space r.
Okay, and what is this?
R into s.
Okay, what is this?
A.
What is this?
A.
One.
If If A is what?
Invertible.
Invertible. And what is this? K, scalar. It is a scalar.
K inverse into A inverse.
No. One by K, A inverse. Can you prove this? Can you prove this? Simple. Just follow the previous steps. I'm just considering a matrix K times A. Okay? And just multiply with 1 by K A inverse. What is the result? K will be cancelled out and that will be identity. What does it mean? The inverse of this will be what? This. It's correct or not?
Yes, sir.
Yeah. Now let's move to the properties of transpose. First property. A transpose of the transpose equal to what?
A, na?
Do you have doubt? A plus B transpose? A minus B transpose K times A transpose. Tell me,
Sir,
what is
second
this?
one is
A
A
transpose
transpose
plus
plus
B transpose.
B transpose.
Okay, what is this?
A transpose minus B transpose.
What is this?
K into A transpose.
There is no transpose of K because it is a scalar. What is AB transpose?
B
A
transpose
transpose.
into A transpose.
B transpose A transpose. What is A transpose inverse? A inverse then
A,
transpose.
sir.
Okay, now the seventh property. A matrix A is said to be symmetric if what is the condition? What is the condition? A matrix A is said to be symmetric if what? A transpose equal to A. What is another condition? Will it be always same? It should be what? Square matrix. Correct or not? Tell me.
Yes, sir.
Yeah. This is A, this is B. A matrix B is said to be skew symmetric if,
A transpose equal to minus A.
but I'm asking about B. B transpose equal to minus A.
Minus
Yeah, eighth property. Any square matrix. Any square matrix A can be decomposed into what? Decompose into what? symmetric and skew symmetric such that A equal to half of A plus A transpose plus half of A minus A transpose. Okay, so this matrix is said to be symmetric and this matrix is said to be skew symmetric. Okay, till now it's fine.
Yes, sir.
Yeah,
Yes, sir.
and also if B is symmetric matrix, then what is the status about B transpose, and what is the status about B transpose B? Is it symmetric or antisymmetric or skew symmetric? If B is symmetric matrix, then B transpose is what? Let's check this. I will just make the transpose of this. What will be the result? What is the result?
B.
B transpose and B transpose, right? What is this?
Yes, sir.
B
B
transpose.
into B transpose.
What does it mean? The transpose of this is exactly equal to this, which means that it is symmetric. And what is the status of this? Is it symmetric or not? What is the result? Symmetric. Okay, now let's move to one question. Show that if A is invertible and AB equal to AC, then what will be the result? What should be the result? Tell me.
B equal to C.
B equal to C. Can you prove this? Take 15 seconds and prove this.
Sir, taking A inverse, sir, in
Yeah.
both the sides.
Yeah, exactly. The given condition is AB equal to AC. Now take inverse both side. Using associative property of multiplication, what is this? Identity. What is this? Identity.
Identity.
B equal to C. Okay. So if AB equal to AC, then we can write B equal to C if A is invertible. So that is the condition. Otherwise, you cannot write it. Now let's take another question. so that so that if A and B are square matrix such that AB equal to 0, if A and B are square matrix such that AB equal to 0, show that B equal to 0 if A is invertible. Easy or not?
Taking any words.
Yeah, just taking the inverse. Okay.
Yes.
Fine.
Yes, sir.
Yeah, tell me. What happened? Are you asking something? No? Now let's move to
Sir,
yeah.
the green color is not visible on the black background.
Okay. Okay, fine. Should I write it again?
No, no, it's fine now.
Okay, I will not use it again. Okay.
Sir, use yellow, sir.
Okay, fine. Okay, I will use it again. Okay, so let's move to the elementary row operation. Row operation to find inverse of matrix. Okay. Is it fine? Is it fine or not?
Yes, sir.
Or should I use more bright?
It's fine.
This one?
The title one is fine.
Okay, fine. Okay, so a n by n matrix is called an elementary matrix if it can be obtained from the n by n identity matrix by performing elementary row operation. Are you getting what it is saying? Read this sentence, then tell me. Are you getting?
Yes, sir.
Yeah, it is saying that
So
Suppose,
it is the same that we
yeah, yeah.
the same
Suppose,
operation that we I is equals to b. We operate on the pivoting points of matrix.
okay, okay. Let's check it. So suppose you have an identity matrix. Okay, 1 0 0 0 1 0 0 0 1. Okay. Now you are performing row operation such that R2 changes to R2 minus 2 R1. Okay. So when you do this kind of operation, any kind of row, elementary row operation, so the changed matrix, the changed identity matrix will be what? When you do the same operation on this, so that will be 1 0 0 0, not 0, minus 2, right? Minus 2 0, sorry, minus 2 1 0 0 0 1. So this is called elementary matrix. Okay. Any kind of operation, any kind of elementary row operation, when you do on the identity matrix, that matrix is called elementary matrix. Elementary matrix. Why I am doing this? There is an application. Suppose you already know that A equal to IA, right? Is it correct or not? A equal to IA.
Yes, sir.
Yeah. Now what?
Yes, sir.
Yeah. Now what I'm trying to do is I am doing such operation on A. This operation. I'm doing this operation on A. Then it will be transformed into A dash. So what I'm trying to do is whatever I am doing the elementary row operation on A, I will do the same operation on I dash. So that will be changed into E matrix, right? E matrix. And when you multiply with A, E with A, then that will result into the A dash matrix. Okay, are you getting what I'm trying to say? I'm saying is I already know that A equal to IA, right? So whatever I am doing elementary row operation on A, that will change into A dash. And that same operation, what will I do is I will perform on identity matrix. Then that matrix will be changed into E. So it means that whatever you are doing the same operation on I, that will change into matrix E. Then when you multiply with elementary matrix with A, that matrix will be exactly equal to the A dash. Okay, let's take an example. Suppose you have a matrix 1 2 3 2 4 5 1 9 6. Okay, I will try elementary row operation. R2 change to R2 minus 2 R1. What will be the resultant matrix? 1 2 3. Next 0 0 minus 1 1 9 6. Okay, that is the A dash. Now what will I do is I will do the same operation but on the identity matrix. Identity matrix is what? 1 0 0 0 1 0 0 0 1. Then I will do the same operation, that is R2 change to R2 minus 2 R1. Okay, so the first elementary row matrix is 1 0 0 minus 2 1 0 0 0 1. Now I will multiply E1 with A. 1 0 0 minus 2 1 0 0 0 1 1 2 3 2 4 5 1 9 6. You will get what? The same matrix 1 2 3 0 0 minus 1 1 9 6. That is nothing but equal to A dash. So what did you do here? So A dash equal to nothing but A1 into E1 into A. Are you getting?
Yes, sir.
Yes, sir.
So I will use the same funda to find the inverse. Okay, what will I do is here, suppose I already know that suppose you have A equal to A, I already know that. Okay, so I can write A times A equal to A. Then what will I do is I will do the same operation on I, and that operation will be changed to A. So suppose you are doing first elementary operation on I, and then you are multiplying with A, that will change into A dash, right? Now you are doing the second operation E2 E1 A, that will change into E double dash. Now you are doing n kind of such operation. And that change into that change into I, then what does it mean?
GE matrix is inverse of A.
Yeah, if you are consider this is equal to B, which means that BA equal to I, which means that what? B equal to A inverse. Are you getting or not?
Yes.
Sir,
Yeah.
Yes.
it is the same that we used to do in the high school for finding the inverse of A by the row operations.
Yeah, yeah, same. The thing is, you don't know. Earlier you didn't know, but the logic behind that was this. I will give an example. Suppose you have a matrix A equal to 1 2 3 2 5 3 1 0 8. Okay, what will I do is I will write I will write a matrix in an augmented form. So what is that augmented form? 1 2 3 2 5 3 1 0 8 dot 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 1 0 0 0 1 0 0 0 1. So I will try to convert this matrix into inverse, and I will do the same operation on this. And also I forgot to mention, suppose here only. Suppose you are doing some operation, elementary row operation on identity matrix, and that is changed into E1. Okay. Now you are doing subsequent another row operation by E2. Okay. Now A has changed into A times E1 and E2. Okay. Now I'm trying to say is, by doing this different operation on A, you can do the same operation. I mean, in one shot, if you do like some kind of operation E times A, instead of doing different operation, at the place of that, if you do the same operation on single identity matrix, that will exactly equal to A dash, A double dash. Are you getting what I'm trying to say? Instead of doing different elementary operation, you can do the same subsequent operation on a single identity matrix, that will also be a same. Are you getting?
Yes, sir. Yes.
Yeah. So here what I am trying to do is, suppose this is the augmented matrix, right? Tell me.
Yes.
Now I will try to convert this matrix into identity matrix, and I will do all those operation on this identity matrix. So which means that this, when this will convert it into identity matrix, this will be what? This will be what? Inverse of A.
Inverse
Yeah.
of A.
So the same logic we are using here. So, suppose you are doing first elementary row operation R2 change to R2 minus 2R1. Then what will be the resultant matrix? 1, 2, 3, 0, 1, minus 3, 0, minus 2, 5. And this will be what? 1, 0, 0, minus 2, 1, 0, minus 1, 0, 1. Okay? Now, I will do another operation. R3 change to R3 plus 2R2. Okay, I could do this kind of operation from another identity matrix, but instead of doing that, I will do the same operation on this matrix alone. The result will be same.
Sir, you have already applied the third row operation on the R3.
Okay, yeah. R3 change to R3 minus R1. That's right?
Yes.
Yeah. Now R3 change to R3 plus 2R2. If we do this, what will be the result? 1, 2, 3, 0, 1, minus 3, 0, 0, minus 1. And what will be this? 1, 0, 0, minus 2, 1, 0, minus 5, 2, 1. Okay? Now I will do another operation. R3 change to minus other. I will make this is unit. 1, 2, 3, 0, 1, minus 3, 0, 0, 1, 1, 0, 0, minus 2, 1, 0, 5, minus 2, minus 1. Right? It's correct or not?
Yes.
Yeah. So now let's move to another operation. That is R1 change to R1 minus 3 R3. This will be 1, 2, 0, 0, 1, 0, 0, 0, 1, minus 14, 6, 3, 13, minus 5, minus 3, 5, minus 2, minus 1. And the last operation, R1 change to R1 minus 2 R2. So 1, 0, 0, 0, 1, 0, 0, 0, 1. That will be minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. So you are able to convert A into identity matrix. So this is what? A inverse. Okay, so A inverse is equal to what? So this is the way to find the inverse by using elementary row operation. Do you have any questions from here? Tell me.
No, sir.
Sir, previous slide, sir.
Huh?
Sir, previous slide, sir. I have to take screenshot.
I will share the link. I have already shared the link in my YouTube channel. You can look into it. Did you check that
Okay, sir.
whether that is working or not?
Yes, sir, it's working.
Yeah.
Working, sir.
Yeah, fine. Okay. So you can clearly see that here we are able to find the inverse because we are able to convert A into identity matrix. That's why we are able to get A inverse. Otherwise, you know, you are not able to get the identity matrix. Suppose you got some this kind of matrix. This means that it is not identity matrix. So which means that inverse doesn't exist. Which also means that A is not invertible. Fine? Tell me.
Yes, sir.
Yeah.
That means one row or one column is completely zero means inverse not exist.
Yes. If you are not able to get identity by doing any kind of row elementary operation of matrix A, if you are not able to get identity matrix, it means that A inverse doesn't exist, which also means that A is not invertible.
Okay.
That it is the same theorem as we already discussed. Okay, identity matrix means what? That is nothing but the row reduced echelon form. That is nothing but the row reduced echelon form of what? Square matrix. Row reduced echelon form of a square matrix is what? Either all elements are 0 or identity matrix. Are you getting what I am trying to say?
Yes, sir.
Yeah.
Yes, sir.
So these things are clear, right? Okay, so today's lecture is over. We'll talk about the remaining things in next lecture.
Thank you, sir.